What's up, fellow polymaths? In this video of the Java Fundamentals tutorial, we'll be going over exception handling. An exception is a problem that arises during the execution of a program. When an exception occurs, the normal flow of a program is disrupted and the program terminates abnormally. Because of these unintended results, these exceptions need to be handled. Exception handling enables you to handle the runtime errors so that the normal flow of the application can be maintained. An exception can occur for many different reasons. Some of the reasons for why an exception can occur are entering invalid data, a file not able to be found, a system error, or some other reason. Some of these exceptions are caused by the user error, others by the programmer error, and others by physical resources that have failed in some manner. There are three categories of exceptions. Checked exceptions are an exception that's checked by the compiler at the compile time. These are also called compile time exceptions. These exceptions can't be ignored. The programmer needs to handle these types of exceptions. And some examples of checked exceptions are I/O exceptions, which are input-output exceptions, and class not found exceptions. So basically, you can think of checked exceptions as the exceptions that occur before the program is actually running. Unchecked exceptions are exceptions that occur at the time of execution, also known as runtime exceptions. These include programming errors such as logic errors. Runtime exceptions are ignored at the time of compilation. Examples of unchecked exceptions include array index out of bounds exceptions and null pointer exceptions. So unchecked exceptions, you can think of them as exceptions while the program is currently running. Errors are not exceptions, but are problems that happen that are beyond the control of the user or programmer. The errors are typically ignored in the code because you can rarely do anything about the error. Errors are ignored at the time of compilation. These include network outages and the Java virtual machine out-of-memory errors. So here's a diagram of the exception hierarchy. We have our java.lang, and then we have the object, and then the object contains a throwable class, and then the throwable class contains the errors as well as the exceptions, and then the exceptions contain the runtime exceptions and the other exceptions. So now that we're familiar with exceptions, we need to understand how to handle those exceptions. The try keyword is used to specify a block where we must place our code that may potentially generate an exception. The try block must be followed by either the catch block or the finally block. The catch block is used to handle the exception. The catch block must be preceded by the try block. This can also optionally be followed by the finally block. The finally block is used to execute the necessary code of the program. It is executed whether or not there's an exception. So for example, if you get some type of exception, but there's a certain code that you need to be executed, you use a finally block in this case. The throw keyword is used to throw an exception. And the throws keyword, remember, throws with the S at the end, is used to declare an exception. It specifies that there might be an exception in the method. So it doesn't throw an exception, but it's always used into the method signature. So in this case, if you think that if there might be a potential exception in that method, you'll use that throws keyword. Of course, with exceptions, there are different ways that you can handle them, and you don't need to use every single keyword. The most important ones you should consider, especially if you're a beginner, are the try, the catch, and the finally. Although the throw and the throws are definitely important. So just one more thing to discuss before we get into the code. So we have two methods that are part of the exception class that have detailed messages. There's the get message, which returns a detailed message about the exception that's occurred. And then there's a print stack trace, which prints the result of the toString. So the print stack trace method gives us a lot of detailed information about the exception that occurred. So now that we have this information, let's go into the code and try to handle some exceptions. All right, so here in the code editor right now, so the first thing we'll do is intentionally generate an exception. All right, so I created two variables, one called a numerator and one called a denominator. I created a print line output, which takes the numerator and divides by the denominator. So as you can see here, the numerator is 10 and the denominator is 0. If you have experience with division, I'm sure you can determine what's going to happen. So let's see what the result is. All right, so we see our output. So exception in the main, we have an arithmetic exception, division by 0 error. So as you're aware, you can't divide by 0. If we don't want to see this exception right here, then we can use the try catch block to handle for that exception. So let's do that right now. All right, so I created the try catch block. The try keyword is followed by some curly braces, and inside that, the curly braces of the try keyword, you include the code that you want to be handled. And this was the code that we created when the division by 0 error happened. after the try keyword, we have our catch block, and this catch block is where the exception is handled. So here we're specifically saying that we want to generate an arithmetic exception because we only expect that exception to occur. And then after that, we have our e.get message, which will output a message about what the specific exception occurred. All right, so let's run this right now and see what we get. All right, so we get the message division by 0, which was the same message that we got before, but this time we don't have the red font, as well as the main method being able to exit gracefully. So after this catch method, you can still continue on with the program if you want to, rather than the whole program shutting down. And let's contain a finally block to just execute some code after the division by 0 exception. All right, so here in the finally block, I created a print line statement called the main method finish executing. So this is going to output after the print line statement in the catch block. So let's run this code right now. So here we have our result after the division by 0 output. We have the main method finish executing. So this try catch block allows any potential exceptions to be handled. And after the exception is handled, you can continue on with the code rather than the program crashing. And this finally block basically executes anything that's required. And usually you'll see the finally block when it comes to things such as resource handling or file inputs and outputs. All right, so back at the PowerPoint slides, try block can be followed by multiple catch blocks. And the syntax is basically where we have our try block code, followed by the try code is the catch block. And you can have as many as possible after the try block. So think of this as a game like Duck Duck Goose. The catch blocks will represent the ducks, and there might be one potential goose in that catch block. This type of syntax was before Java 7, but Java 7 simplifies the code for handling multiple exceptions. So in Java 7, you can handle more than an exception using the pipe symbol. So instead of having multiple catch blocks, which can make a class quite long depending on how many exceptions you have. So all you have to do is inside the catch block, within the parentheses of what exception type that you want to handle, you just add the pipe symbol in between those exception types. And this simplifies the code, reducing the number of lines in the code. So now that we know this, let's try this out. We're back in the same code that we were at before, and I'm just going to add a couple of exception types. All right, so I added 2 more exception types. So we have a total of 3 exception types in this catch exception. So just as a note, so the first exception type that's caught is the one that comes at the beginning. So in this case, the program checks if it's an array index out of bounds exception, and if it's not, then it checks if it's a null pointer exception. And if it's not a null pointer exception, it checks if it's an arithmetic exception. And if it is, then it'll output the print line statement. So let's run this right now. All right, so we got the same error, arithmetic exception. So we saw that the program checked that if it was not an array index out of bounds exception or a null pointer exception, but it saw that this program was an arithmetic exception, which is why it outputted that division by 0 message. So let's change up the code a bit and determine what happens when none of these exceptions apply to the code. All right, so I changed up the code. So basically what we have here is we have a string variable called name, and we assign that as null. And then we have our output checking the length of the name, which is null. Try to guess what happens when we output this program. All right, so we see our result. Even though we got the finally block that was executed, an exception occurred, which was a null pointer exception. Even though we have our catch block, it's only checking the array index out of bounds exception and the arithmetic exception. Because of the exception, the null pointer exception doesn't fit the criteria, that means that an exception was raised, which would end up potentially crashing the program, despite the finally block being executed. So a way to handle this is to have a catch-all for this. And in this way, you can just put exception, and this exception is basically a catch-all for all types of exceptions. Of course, it's best to be specific on what type of exception that you get, but if you're not sure what type of exceptions might occur, this exception makes it easier to catch all types of exceptions. So I'll run this program right now and we can see the result. All right, so here we have our result. So the catch block did catch that null pointer exception and the output was null. And we have a finally block that was executed. If you want to see a more granular exception message, we can use our print stack trace. So here we added the print stack trace, and then we're going to be running this code right now. All right, so we executed the code and we see here that we it outputted the null from the e.get message. And then after the empty print line statement, we see that the print stack trace shows up a java.lang.null pointer exception. So even with this, since we have the whole catch block, we are able to handle the exception and keep the program running since we had the catch-all for the exception. So just briefly discussing the throw and throws keyword. If a method doesn't handle a checked exception, the method must declare the exception using the throws keyword. The throws keyword appears at the end of the method signature. You can throw an exception, either a newly instantiated exception or an exception that you just caught by using the throw keyword. The throws keyword is used to postpone the handling of a checked exception, and the throw keyword is used to call an exception explicitly. A method can declare that it throws more than one exception. These exceptions are declared in a list separated by commas. All right, so we're back in the code. Here's a simple example of the throws keyword. So here, after this method signature of the main method, we can just add in throws IO exception, and this can be any type of exception that you're expecting. And if we want to add more than one exception type, we can just add a comma and then the exception type. So in this case, the main method will be throwing the IO exception and the class not found exception. So just one more thing to discuss about exceptions. Java allows for creating custom exceptions. When you write your own exception classes, all exceptions must be a child of the throwable class. If you want to write a checked exception that is automatically enforced by the compiler, you need to extend the exception class. And if you want to write a runtime exception, you need to extend the runtime exception class. So the syntax for this is basically after the class name, you extend the exception class. And that's pretty much it in terms of how you create your own exceptions. An exception class can be like any other class, which contains variables and methods. This isn't really done that often, but there might be some edge cases where you might need to create your own exceptions depending on what you're specifically doing. All right, here's our assignment for this topic. Number 1, what are the 3 types of exceptions in Java? Number 2, what type of exception is an array index out of bounds exception a type of? Number 3, write a program that tries to divide by 0 and handle the exception. Number 4, adding on to number 3, use the finally block to output a simple string message. Number 5, true or false, you can handle multiple catch blocks within the try catch block. If this video was of any value to you, then please leave a like, comment, share, and subscribe. Thanks for watching, and I'll see you later.